Okay, so the next part of today's lesson has to do with scientific notation and standard form. Okay, so once again, as I usually like to do, I don't really care what you remember about doing these problems. Just do whatever you can remember. And if you don't remember what scientific notation is, that's perfectly okay. If you don't remember what standard form is, that's a little bit less okay, but I get it. But if you kind of remember, standard form and scientific notation, here's what I think, that would be best. And then I'm gonna go ahead and let you guys pause it, and then when you come back, we will talk a little bit about it. And I think I will be able to jog your memory on scientific notation in standard form, and then we will move on from there. Okay, so take a moment to pause and then go ahead and convert each of these to either standard form or scientific notation. Note that I did not tell you which one you're converting to, so I'm going to erase some of those random marks there. Okay, so go ahead and press pause, and then we'll come back in just a second. Okay, so I'm assuming you had a chance to do what you can remember. I'm not sure how much of it is you remember this, and I keep saying that because scientific notation is not necessarily something that people use very often, mainly because most of us are not scientists. So unless you are a scientist, you probably don't use this on a daily basis. So you may not have done this for a number of years, so it would be understandable that you don't really remember it. But it is something that we teach our students, and the reason we teach our students is because we don't know when they're in elementary school if they're going to be a scientist or not. We don't want to pigeonhole them or make, not give them the skills that they need to become a scientist when they're in elementary school. So we teach everybody everything. Some will move on to be scientists and they will use this all the time. Others of us will not ever use it after we get out of school, and that's fine. The information is not necessarily bad. Helps you understand what scientific notation is, but that way, at least for sure, we're not saying, well, you're never going to be a scientist, so I'm not going to teach you the content. We're going to teach everybody everything, and then they get to decide later if they want to use it or not use it. Okay, so if we look at this, scientific notation. So I'm guessing some of you, when I said this, when you looked at these problems, you remembered something about moving left and moving right and something about the exponents. And then there was a certain way that the answer had to look in order for it to be in scientific notation. Those are probably the things that we remember. So I'm going to go ahead and talk briefly about what scientific notation is. So this one is written in scientific notation. Okay, that one is written in scientific notation, as is this one down here. So both of those are scientific notation, which means that both of these must be standard form. Okay, so that's a standard form notation, and that's a standard form notation. So let's take a look and see if we can tell the difference. So what's the difference between scientific notation and standard form? Well, you might look and notice that in scientific notation, it looks like a problem. There's like a little calculation we have to do. And this is really one of the very, very few times that I use that symbol for multiplication. I never use the parentheses on this because that just looks kind of weird. I actually use this x, so that means that 3.042 times 10 to the second. And down here we have 5.21 times 10 to the negative third. So you probably noticed that the two top and bottom ones had something in common in that they both have times 10 to the something, okay? And that's true. Scientific notation always has times 10. So I'm going to put a little box around that. So it always has times 10. It's never going to be times 7 or times 3 or times 8. It's always times 10. And the reason that is because we use base 10. Since our counting system is base 10, we're going to use base 10 for our scientific notation. So it always has times 10 to the something. And then the other thing that you might notice is that it has an exponent, and that's also true. Okay? And sometimes the exponent might be 1, so you may or may not write the exponent. If it was times 10 to the first, that's an option of whether or not you're going to use the exponent or not. It still would be scientific notation. But for the most part, we have exponents here. Okay, so times 10 to the second or times 10 to the negative third. And then the last thing that I'd like for you to notice, and it's probably the hardest thing to remember back in the day, is that scientific notation always looks like this. And what this looks like is, and this one's kind of got erased there, so let me put it back in, is it's always a number that is in between 1 and 10, okay? So basically it's a 1-digit number that's bigger than 1. So 3.042 works, 5.21 works, 3,562 does not work because that number is bigger than 10. 0.0426 does not work because that number is less than 1. Okay? So scientific notation has 3 things to it. It has a number that is between 1 and 10. It has multiplied by 10. So it's always times 10 to the something. And the third thing it has is an exponent. Exponent could be positive or the exponent could be negative. It doesn't matter for scientific notation. Okay? So standard form means we don't have all of that stuff. I don't care if my number's between 1 and 10. I don't care if I have, in fact, I'm not going to have times 10 to the something, and I'm never going to have an exponent. All right? So scientific notation, those are the numbers we're used, standard form, those are the numbers that we're used to writing all the time. So pretty much all the numbers that you've been writing your entire life are called standard form, and then a very specific type of problem is this scientific notation. Okay, so that's the brief review of what scientific and standard form are. And now you might be going, oh, that's right, I remember some of this stuff. I got to move my decimal and this and that. So sometimes we move them left and sometimes we move right. And I will tell you from my own upbringing, and it might be because of my dyslexia, but I always struggled with converting scientific notation. And the reason I struggled is because my teacher always said, moving left, moving right, da, da, da. And for me, I could not keep clear when I was moving left or why I should be moving left and why I should be moving right. It just didn't make sense. And again, it might be my dyslexia that was such a problem because other people did not seem to have a problem. But when I started teaching this, 20 years ago, I thought, all right, well, if I had trouble with it because of whatever reason, perhaps my dyslexia, I probably have students who also are going to have dyslexia or my same issue. So is there a different way that I can explain it? Because it was a struggle for me. And in fact, it was such a struggle for me that when I tried to teach it that way, I really didn't know how to do it. Like I could not figure out if I was supposed to be moving left or if I was supposed to be moving right. So I'm going to do what I think I remember about moving left and moving right. Okay, so here's what I think I remember. I think I remember that when the exponent is positive, that means you're going to be moving your decimal place to the right. Okay, so when the exponent's positive, you move your decimal place to the right. So I'm going to move it from here. If I'm moving it right, then I'm moving it in that direction, and I'm going to move it that many times. So I'm going to go 1, 2. So my new decimal point is going to be between the 4 and the 2. So my number in standard form then is going to be 304.2. Okay? That's what I remember about moving decimals left and right. That this tells me how many I'm going to move, and I'm moving to, and because it's positive, I'm moving to the right. Okay? Now, this one down below, I'm in standard form, but I'm going to go to scientific notation. So in order to have this in scientific notation, I know that I need to have a number that is between 1 and 10. So right now it's less than 1. So I have to move my decimal point so that it's going to be a number between 1 and 10. So I'm going to move my decimal point 2 spots. So my new number is 4.26. Okay? And then I know that I have scientific notation is always going to be times 10. And then I need to figure out what my exponent is. Well, I know that I moved my decimal point 2 times, so I know it's going to be a 2. And here's where I struggled. If we look at this, I moved my decimal point to the right, and it was positive. Here, I'm moving my decimal point to the right, yet this one should be negative. And that was my struggle. I could never remember why was this one positive and this one negative with just trying to memorize moving left and moving right. So about 15 or 18 years ago, after frustrating myself trying to explain this and having kids being confused and knowing their confusion was my fault, not theirs, I completely did it differently. And I did what I think we always should do is use understanding to solve our problems. Don't have them memorize. When it's positive, I move to the right. When it's negative, I move to the left. Because here it's negative and I didn't move to the left. I moved to the right. And it's just, So don't try to have them memorize a bunch of rules. Have them understand. And if we think back what the notes were just a second ago about what a negative exponent means and what a positive exponent means, we can make some predictions about what my answer should look like. So now I'm going to slide this over and I'm going to rewrite those problems that I have there just so I have some more room. So my first problem that I had, number 1, was 3.042 times 10 to the second. Okay, if I understand what exponents are telling me, then what does this exponent tell me? Well, this number is telling me, since it's positive, that this number that I'm going to have when I'm done needs to be bigger than 1. It needs to be a very big number. So since that's positive, I need to make sure that this number ends up, when I'm done converting it, it ends up being positive. Okay? So the other thing that this number tells me is it tells me how many times I'm moving my decimal place. So what I'm going to do is I'm going to say, here are my digits, 3, 0, 4, 2. Okay? And I need to move this decimal point. I need to move this decimal point so that when I'm done moving it, my answer is a lot bigger than 1. So I have 2 choices. I could move it this direction, 1, 2, and then put a 0 in there. And then is that bigger than 1? Or I could move it this direction, not saying left or right, but move it in either this direction or the opposite direction, and then put it in there, and would that number be bigger than 1? So of course, we already know the answer. So if the decimal started here and I need my end result to be bigger than 1 because this is positive, then I would have to move it to right there. So my new answer is 304.2. Now I know you're probably going, that still seems like you're telling me to move left and right. I'm not, right? We're going to take a look at another one here, and we're going to see how I never mentioned left or right. I mentioned bigger or smaller than 1. So here we go. This is number 4 from down below. 5.21 times 10 to the negative third. Okay? So now, when I look at this problem, I know that when I'm done with doing this problem, my answer has to be what? So because that's a negative, that means my answer has to be less than 1, smaller than 1. And I know I have to move it 3 times. So if I move this, and I'm only going to go one direction or the other. If I move it this way, is this number less than 1? Well, that's 5,210. No, it's not less than 1. So the only direction I can move it is this direction, 1, 2, 3. And then I put my decimal point in there and then 2 zeros. And so my final answer then becomes 0.00521. And then I can look, is this number here makes sense for that exponent? Well, this number is less than 1. That exponent should be less than 1. So it makes sense to me. Okay? Now, looking at the next one, going on to number 2. Okay, now we're going from standard form into scientific notation. So I do need to remember a couple things about scientific notation. And the first thing is that it always has to be a number between 0 and 1, right? 0 and 10. So that means my new decimal point needs to be right here. It's the first two non-zero numbers. That's where I'm going to be moving it to. So that's where it needs to be. So I'm going to be 4.26. Okay. Now, since I'm going to scientific notation, I know it's going to be times 10. It's always times 10. And now here's my question. I do the exponent next. Is my exponent going to be a positive or a negative if this is my starting number? So if my starting number is 0.0426, is my exponent positive or negative? Well, since this number is less than 1, that means my exponent has to be negative. So it's going to be negative something, and then all I have to do is figure out how many times did I move it. Well, looks like I moved it 2 times, so it's going to be -2. So my answer is 4.26 times 10 to the -2. Okay? So I never worried about, am I moving left or moving right? I'm saying, is this number bigger or smaller than 1? That's all I care about. If it's bigger than 1, my exponent's positive. If it's smaller than 1, my exponent's negative. And then I just count how many times I have to move it. Okay? Now for the last one here. And this is probably the trickiest one. And I'll explain why this is extra tricky. Maybe you can figure out why it's extra tricky. So what makes this one a little bit harder than the other ones that we've done? Well, when you look at this one, we don't see a decimal point. And I know that we probably are like, oh, that's no big deal. I know right where the decimal point is. You'll be amazed at how many of your students have no idea where the decimal point is. I have tried so many different ways. Write a sentence. Where's the decimal point? You know, where's the period when you write a sentence? It's at the end of it. Put it over here, right? There's no connection. I have had a very difficult time getting students to understand where that decimal point is. But they do need to know that that decimal point, even though I have it written, is sitting right here. Okay, so that's where it is, even though I can't see it. So here's how I have my students draw these problems out a lot. So what I'm going to do is I'm going to do the easy stuff, the stuff I know. I know I'm going to have times 10 because scientific notation always has times 10. And then I'm going to have an exponent, and that exponent is either going to be positive or negative. And I can determine the exponent based on what this number is. Is this number bigger or smaller than 1? If it's smaller than 1, then my exponent's negative. If this number is bigger than 1, then my exponent is positive. And since 3,562 is bigger than 1, for emphasis, I put the positive there. Of course, you don't have to put it, but I always put it there for emphasis when I'm teaching this. Okay, now, the next thing I got to do, or the last thing I got to do, is I got to put my decimal point in the correct spot. And we know that the number in scientific notation needs to be between 1 and 10. So the only place I can put that decimal point is, if I put it there, is that number between 1 and 10? Of course not. If I put it here, is it between 1 and 10? Of course not. And then if I put it here, is the number between 1 and 10? Of course. So my number is going to be 3.562 times 10 to the something. Now, if they don't know the decimal point goes there, then they're going to screw this up. They're going to go, oh, I moved it 1 time to right there. Of course, that's not right because the decimal point's over here. So I moved it 1, 2, 3 times. So my answer is going to be 3.526 times 10 to the positive third. And I never talked about moving it left and never talked about moving it right. Okay? Okay, so that's the whole notes, right? So you can have some homework tonight based on the exponent stuff and whether numbers are bigger or smaller than 1, and then changing from scientific notation to standard form and back. So that's it. The notes aren't too bad today. It's just scientific notation, and I will see you guys or talk to you guys soon.